When people think about racing, the first thing that they think is about how much fuel you are spending. For me, sustainability is more than that. Sustainability has to do with how are we going to make each one of our employees' lives better. When we are developing an engine, how do you do that with less fuel, less electricity, less time on that dyno? When we are working on parts and fixture and so on, instead of having a prototype, how do you do that through a software in the computer? And that is where you at the end try to get the right partners that can help you to make all of this more efficient, reduce costs, make it more sustainable, but at the same time trying to accelerate your development.
NASCAR's rulebook is pretty stringent. Not only do they limit our wind tunnel time, but they also limit our CFD time. So that means if we're going to find performance, we make our money in the margins, and they're very, very small. And when it comes to complex geometries like we have, that becomes a really difficult proposition.
Before simulation, we weren't able to test engine parts at engine operating conditions. In the olden days, if we want to evaluate 10 different designs, we would literally manufacture each one of those parts and test all 10 of them. We need optimization capabilities to come up with a better design in less iterations in less time, using less compute resources.
What Siemens and NX offers with Teamcenter, STAR, the ability to collaborate, the ability to have design engineers and aerodynamicists side by side, that shortens our time to market, that shortens our time to track, and that results in performance for us.
One of the beautiful things about our usage of NX is the ability to collaboratively work in an assembly where we can have multiple engineers working on different parts of the assembly or sub-assemblies, and some can work on different prints or some can work on different components all at the same time. Ultimately, the race car going faster is made by the people who are making it go faster. So anything we can do to improve their processes, whether that be a tool that they're using to measure the race car or measure a part on the race car, or perhaps even put that together, as long as we can speed that up and make that more efficient, that basically shortens their workday or allows them to focus more detailed on another task at hand.
The thing I really like about the integration of STAR is that it integrates really well with NX. And so for us, that allows our designers to make changes, help and work and design and tee things up for the CFD, but the CFD designers are also able to make small changes at the same time. For instance, if they see a hot spot or if they see a potential area of opportunity, they're able to adapt really quickly, make those changes and rerun that. For us, STAR has really become a platform where we can really quickly design, we can iterate through ideas, we can mesh things, we can get results out of there. The results of the optimization have really helped us in terms of sustainability. In our sport, fuel mileage is a huge deal, and that last mile to win the race on fuel mileage at some point becomes a drag equation. So if we can make our cars more efficient, which is the end goal, and we can squeeze performance out of that using optimization routines in STAR, we're able to not only create a car with more downforce but less drag, and that also has the impact for sustainability. We burn less fuel, and at the end of the day, that equates to wins for us.